Hey there, hope you're doing good. Today we'll talk about horizontal versus vertical scaling. Which one should you use and when? Before we begin, let's define the terms. Horizontal scaling means if you run out of capacity, you use more instances, each of them with the same capacity. So if you're using an instance with let's say 128 MB memory and 1 vCPU, and that's not enough, you use one more with the same resources. Two instances with 128 MB each, not one instance with 256 MB. That would be vertical scaling. With vertical scaling, you have only one instance and the instance gets bigger and bigger. Horizontal scaling has a few advantages over vertical. First, vertical scaling incurs downtime. Because you have only one instance, you have to shut it down, move to a bigger instance, and then turn it up. In the UI, it might just be one click, but it may take a few minutes. If you need to scale up during peak hours, it's a tricky situation. If you ignore the problem, it will be slow the rest of the day. If you bite the bullet and do it, you will have an outage. So either way, there's a problem. And scaling happens only during peak hours. So this problem you are not going to encounter in off-peak hours when you could scale without much impact to users. You're going to be confronted with this problem when there are a lot of users. So that was the first downside of vertical scaling. It increases downtime. It causes downtime. Horizontal scaling does not cause any downtime. It goes smoothly. The next point is auto scaling works only with horizontal scaling. Moving on, vertical scaling requires you to pay for the peak. You can't easily scale down. If you're using a database with 16 GB memory and you have peaks that require 32, you scale up to 32 and then you stick with 32. You can't easily scale down because it incurs downtime. So these are the advantages of horizontal scaling. One, vertical scaling incurs downtime. Second, auto scaling works only with horizontal scaling. Third, vertical scaling requires you to pay for the peak 24/7. Oh, and there's also a fourth one, which is horizontal scaling limits the blast radius of problems that happen in one instance. So if you have 5 instances of your app server and one of them goes into an infinite loop, it takes up 100% CPU, it no longer responds to requests, which is a problem I've seen with one of the startups I worked with. With horizontal scaling, only one of your instances is affected, so your system still works. With vertical scaling, the entire system grinds to a halt. So these are the advantages of horizontal scaling. Some services are designed with vertical scaling in mind and some with horizontal. RDS, Relational Database Service on AWS, supports only vertical scaling. If you're using MySQL or Postgres, these are not designed to be horizontally scaled. So RDS, for example, comes with a few different instance types. You have to use one of these. So if you're using 2 cores and 8 GB and that's not enough, you have to upgrade to 16. The thing to keep in mind is don't blindly upgrade. Find out which one is the limiting factor, memory or cores, and increase that. So if you're using this instance type, 16 GB and 2 cores, and it's not enough for you, don't blindly upgrade to the next one. Maybe your limitation is the CPU, in which case you can upgrade to 16 GB and 4 cores. But understand what the problem is and address the bottleneck. Don't blindly throw resources at it. So this is an example of vertical scaling with RDS. Other services, specifically serverless ones, auto scale horizontally. They are designed that way. It comes built in. This includes functions as a service like AWS Lambda or Google Cloud Functions, where each instance serves only one request at once. So you have to horizontally scale. Furthermore, each instance can serve only one type of request, only one endpoint. So if a request for a different endpoint comes in, it has to spin up another instance. So these are designed to autoscale horizontally. Another example is serverless platforms like Google Cloud Run, which need not be functions as a service, or Google App Engine. These are all designed to scale horizontally. So some services like RDS scale vertically, some like serverless scale horizontally. And if the service you're using falls into one of these buckets, use it. Don't fight the system. Use whatever the system is designed for. In some cases, though, you may have a choice. If you're using EC2 VMs, you have a choice of whether to use horizontal or vertical scaling. You generally want horizontal scaling specifically for your app servers. Let's discuss app servers, not database or caches or other things. For app servers, you generally want horizontal scaling for a few reasons. One is it supports canarying. One good deployment practice is to have a canary which handles 1% of your traffic. And the canary is running 24/7. And you use continuous deployment with the canary. So whenever an engineer commits code into Git, after it is code reviewed, after automated tools like SonarQube run, assuming you have code reviews, and after all the tests pass, it is deployed to the canary immediately. And it's deployed to the main servers later on. So that is canarying. It's a good practice. And if you're using it, you have to design for horizontal scaling anyway because you have multiple instances running. Even if you don't have a canary, during deployment of a new version of your software, you temporarily have a new instance running in parallel with the old one. So you again have to design for horizontal scaling. And it isn't hard. You have to follow basic practices like not having in-memory caches and using Redis. Assuming you need it, don't blindly use Redis. If you need a cache, use Redis. Because there is caching at lower layers. If you're going to fetch something from the database itself caches it in memory. So you don't necessarily need Redis all the time. But if you do need caching, use Redis and not an in-memory cache. So horizontal scaling techniques are well known and very easy to follow. So for your app server, I recommend that. Hope you found this useful. If you'd like me to guide your team on running services effectively, my consulting link is in the description. If you found this useful and want to learn more, consider subscribing to this channel so that you are notified when I post a new video. Thank you.